Hello, welcome to my YouTube channel FPGA Made Easy. On this channel you will learn about the FPGA technology and programming from basic to advanced level. In this series of videos we started to learn about Verilog HDL from basic to advanced. For more videos, subscribe this channel by click on the subscribe button and follow us on our Facebook page for the notification. For this video our learning objectives are: Number 1. What is hardware description language? Number 2. We discuss about the importance of HDLs. The next one is what are the types of HDL? In the end, brief history of Verilog HDL is described. So let's start. In order to understand what is hardware description language is, consider a simple example described in 3-column table. In the first column, a simple schematic of digital design is shown as an example. Now if someone asks you to describe the digital circuit in your own native language, how would you describe it? For example, if we describe it in English, we say the circuit shown in figure is named CKT underscore XYZ. It has 4 inputs A, B, C and D and 1 output X. There are 2 internal signals or wires S and T. It consists of 3 gates G1, G2 and G3. G1 and G2 are logical AND gates, whereas G3 is logical OR gate. Similarly, in a computer-based language or a software such as C language, we can describe the circuit or logic by declaring inputs and outputs and the structure of program. So we can say that an HDL is a method or a language of designing digital hardware by means of software. There are many advantages of using HDLs in developing digital designs. Few of them are described here, such as using HDLs, it saves a lot of time in designing a system. As technology grows from small scale integration to very large scale integration, number of transistor or gate counts increases drastically. So we use HDLs to implement large designs very fastly. It reduces the time to market for a system. Designs can be simulated and tested for correct functional behavior. Through this way, errors are found during simulation and corrected. Some other advantages are using HDLs. Designs can be described at every abstraction level. HDL is analogous to computer programming and it is easier to understand. Using HDL, it is easy to target new fabrication technology. Now what are the types of HDLs? The most widely used HDL for designing digital designs are Verilog HDL or VHDL, and some other high level languages are also used to develop hardware designs. There are few advantages and features of Verilog HDL we will discuss here. It is a general purpose hardware description language and it is easy to learn and easy to use. Syntax wise, it is similar to C programming language. Verilog allows different level of abstraction and mixed level of abstraction can also be achieved. Verilog can be used with all popular logic synthesis tools. Libraries for simulation for the Verilog designs are available with all the tools. The programming language interface (PLI) is a powerful feature that allows the user to write custom C code to interact with the internal data structures of HDL. Now we discuss some historical background of Verilog HDL. Verilog HDL was developed by Philip Murby in 1984 by the Gateway Design Automation Company. Later, this company was acquired by Cadence Design Systems. This company puts the language in the public domain in 1990. The Open Verilog International was formed to promote Verilog HDL language. In 1995, Verilog HDL was made an IEEE standard 1364 in 1995. It was first revised as IEEE standard 1364 in 2001. This revision corrects and clarifies various features. It also resolves incompatibilities and inconsistencies of above IEEE standard under standard 1800 in 2005. Thank you for watching this video. For more videos, subscribe this channel and follow us on our Facebook page for the notification. Thank you.